Okay, ladies and gentlemen, here we go. Were you able to write down all your perfect squares? Yes? Okay, here we go. Make sure you got them correct. So far, so good? Still good? Still good. Yes? Did I get that last one right? Yeah. Okay. Okay, now, if you read the directions, it said you were supposed to circle your answers. Did you? If you haven't, please do so. There's a reason I want you to circle them. All of those numbers that we just circled are called perfect squares. Because if you take their square root, they are whole numbers. So, grab your calculator, find your square root key. Does everybody remember where their square root key is? Mine's right there. It's in a different color, which means I have to press the second button and then hit that square root button. Type in 900 for me. What is the square root of 900? 30. Is that a whole number? That means 900 is a perfect square. Clear? Okay. How about the square root of 1,000? Is 1,000 a perfect square? No, because it's a decimal, right? How about the square root of 10? Let's do 10,000. Square root of 10,000, is that a perfect square? Yes. So, is 441 a perfect square? Yes. Is 10 a perfect square? 10 is not circled, is it? 100 is a perfect square. Is 10 a perfect square? No. Is 324 a perfect square? Is 20 a perfect square? No. Are we clear on what a perfect square is? Okay. Now, I asked you to work these out for me, and let's see how you did. How was that one? Did you get it correct or no? Okay, some of you are just looking at me funny. You were supposed to multiply this. X times x is x squared. X times negative 3 is negative 3x. Then we get a plus 3x. Then we get a minus 9. If you put those two things together in the middle, they cancel out. Did some of you forget to distribute and work it out? How is the answer, folks? Is it good or not good? Good. So then what did you get for the second one? It should be minus 25. Okay, so those of you that are looking at me blankly right now, do you understand what I'm asking you to do here? You were supposed to chop this in half, and then you were supposed to distribute and combine your like terms. And you should get that 4y squared minus 25. Okay, how about the third one? What is, I actually meant the fourth one, I'm sorry. I don't have the z squared one on mine. How'd you do, folks? Yep, because it'll end up being a negative 9 times a positive 9, which will give you a negative 81. Folks, I'm asking, how'd we do? Good. So I want you to take a look at all three of these answers. And yes, I know I missed one. For some reason I don't have that written on my notes. I'm not quite sure why. I want you to take a look at all those. What similarities do they have? All the variables are squared. What else do you notice? They're all minus. That's key. What else do you notice? All of them are perfect squares. What's in front of this x squared? Is that a perfect square? Is that a perfect square? How about this one? This one? They're all perfect squares, aren't they? Does everybody see that? Okay. Then we move down to these. What did you get for this first one? The final answer. Okay, so we're going to work this out. We've talked about this a month ago, and we've done it a lot, correct? So you can imagine my issue with the fact that you guys are not be able to do this for me right now, correct? Okay, what is 4x times 4x? What is 4x times 3? What is 3 times 4x? And what is 3 times 3? If you put the middle two terms together, what do you get? Is everybody clear on that? Good? Okay. I'm missing another one above that? Okay. How about this one down here? Did you write it twice? Good. And did you chop it in half? And you wrote it and you distributed? What did you get for a final answer? Like that? Okay, so I probably need to apologize for just getting upset with you. Sorry about that. I didn't realize I had 2 missing on there. 3. Okay, is everybody good here? Okay, so now I need you to look at these. This one and this one. And I need you to tell me what you notice. They're all 3 terms, right? These starting terms are perfect squares. They have x squareds on them. The end terms are perfect squares, aren't they? And Gage is telling me that the middle terms are not perfect squares. But let me ask you this. What's the square root of 16? 4. What's the square root of 1? If you multiply them together, what do you get? 4. He just added, that's all. If you multiply them, you get 4. If you double it, what do you get? 8. See that? Okay, how about over here? What's the square root of 16? What's the square root of 9? Multiply them, you get? Double it. See how that works? Any questions on that? We're going to be doing these today. Okay? All right, go ahead and flip it over, please. Should be no surprise to you that the first step when factoring, even though some of you still forgot to do a GCF on that quiz. Okay, if there's 4 terms, we're going to group. Guys, on this whole worksheet, you won't ever have to make a 4-term problem and group it. Okay, you're going to group 2 by 2 if you do have 4 terms. 2 binomials. And if you have a trinomial and you have to make 2 binomials, you either have to do it the short way or the long way. How do you know to do it the short way? Short way if it starts with 1. Long way if it does not start with 1. Okay. Do you have another star down there? Oh, there is a star down here, isn't there? Sorry about that. I suppose you could call it the medium way. We have a short way, we have a long way, we have a medium way. Why not? If it begins and ends with a perfect square, we might be able to do something with it. And I'll show you what that is here in a little bit. Okay? But as I told you, I believe last Friday, I have to teach you how to factor things with two terms, correct? And if you look down at your sheet there, you will have quite a few problems that only have two terms. Okay, so if there are two terms, you need to ask yourself, is it the difference of perfect squares? And if it is, you are going to make conjugates. Now, folks, we have actually talked about conjugates before. That word should be semi-familiar to you. Okay, does everybody have it written down? Because I'm going to go to a different slide. Yes? Okay, so conjugates mean you have the same parentheses, but one is plus and one is minus. Do you all see how those are conjugates? Yes? What happened when you worked them out? You only came up with two terms, didn't you? Which is why, if you have two terms, and they are the difference of perfect squares, you're going to be making conjugates. Okay, so question. Do you want me to start with the new stuff and end with the old stuff, or do we want to ease our way in with the old stuff and then go back to the new stuff? Old stuff, then new stuff. So I would like to please go to number 24. First step, do you have a GCF? Nope. How many terms you got? So what are you going to make? Two binomials. Will this be the long way or the short way? Short way means I start with I need factors of 12 that subtract to 4. Do my symbols need to be the same or different? They need to be different because of the minus 12, and the bigger one needs to be, okay, that is definitely nothing new to you. Good? Okay, now let's go to number 17. Do you have a GCF? Nope. How many terms? So you need to make binomial times a binomial. Long way or short way? This will be the short way because it starts with a 1. We will fill them with x's. You need factors of 35 that subtract to 2. Because it's subtracting to 2, does that mean same or different? And the bigger one needs to be negative. Okay. Over to number 20. Do you have a GCF? Yes. What can I take out of all of those? If you take out a 4, what's left? Oh, not minus 2x. Okay. How many terms do you have in there? 3. Is this going to be the short way or the long way? Short way, which means I need to drop the 4 down. I need to start my two binomials with factors of 2 that subtract to 1. Since we are subtracting, does that mean same or different? Different, and the bigger one needs to be. Do you guys feel like you're pros on this? Kind of? Okay, let's do 2 more of these, and then we'll move on. Let's do number 15, please. It's right there. Do you have a GCF? What? Put your X out front. What's left? How many terms do you have in those parentheses? 3. Short way or long way? Short way because it starts with a 1. Start your parentheses with factors of 1 that make 2. If we are adding to 2, does that mean same or different? And they both need to be. Okay. And finally, let's go to number 21. Do you have a GCF? of what? Y squared. We can take a y squared out of all of them. What is left when you take out a y squared? Okay. Now that we took out the GCF, how many terms do you have in there? 3, which means 2 binomials, and it will be the short way because it starts with a leading coefficient of 1. Did you remember to drop down your y squared? Okay, what am I going to start them with? You need factors of 36 that will add to 12. If I'm adding to 12, does that mean same or different? And they both need to be. Okay, so that should all be good and reviewed for you. Okay? All right. Let's try and do some of those two-termers. Like number 1. Two-termers. First of all, you still got to ask yourself, do you have a GCF? No. So, like it says up there, if there are two terms, is it the difference of perfect squares? Folks, what does difference mean? Subtraction. Do we have subtraction in there? Are they both perfect squares? Yes, 1 is a perfect square and 9 is a perfect square. So that means I'm going to make conjugates. Conjugates mean, that did make it, right? Okay. Conjugates mean they have to be the same thing, right? So what am I going to start these with? What am I going to end them with? They have to be the same thing that will multiply to 9. 3 and 3 will multiply to 9, won't it? Okay, if they're going to be conjugates, they have to have opposite symbols. It does not matter what order those go in. Does not matter the order. Did we make conjugates? If you work this out, you will get that. Good? Number 3. Do you have a GCF? No. How many terms? What? 2 terms in number 3. Meaning, is this the difference? Does that symbol mean difference? Are they both perfect squares? 1 is a perfect square and 25 is a perfect square, correct? Okay, so we need to make conjugates. I need y and y, and then 5 and 5, and they're going to be different. Easy enough. Let's go down to number 6. Do you have a GCF? What can you take out of 49 and 16? 8 doesn't divide out of 49. No GCF. How many terms you got? So is this the difference of 2 perfect squares? So we're going to make conjugates. How am I going to make 49m squared? I need 2 m's, but I got to make that 49, don't I? Nope. 7 and 7 multiply to 49, don't they? Remember, folks, these things have to multiply to make that 49, and they have to be the same if they're going to be conjugates. How am I going to make the 16? 4 and 4. And then if they're conjugates, it's 1 plus and 1 minus. I need you to remember what conjugate means, folks. They both have to be the same. And that means when I multiply them, I got to get the original problem. Good? How about number 7? Do you have a GCF? What can you take out of both of them? Number 7? Can we take anything out of number 7? No. How many terms do you have? So your only option is the difference. Is this the difference? Yes or no, folks? Does that minus mean difference? Yes, it does. Are 64 and 225 perfect squares? If you look at the front of your sheet, everybody flip them over. Do you have 64 and 225 circled? You do, which means I'm ready to make conjugates. In fact, how are you going to make 64r squared? 8r and 8r. How are you going to make 225s squared? 15s, and 15s. And then what do we know about our symbols? They're going to be different. It doesn't matter if you go plus minus or minus plus. We'll get there. All right, let's go to number 14. You got a GCF in 14? I don't see a GCF. How many terms you got up there? Which means they have to be the difference of two squares. Are they? Okay, so we're going to make conjugates. How are you going to make 16d squared? And then 1 and 1. And my symbols have to be different. Okay. How about number 26? Do you have a GCF? How many terms? Are they the difference? And are they perfect squares? Okay, so we're going to make conjugates. Wonderful. Pretty good, right? Okay. So now I want to back up to number 22. And I want to ask you if there's a GCF. I don't see a GCF. How many terms do you have there? Is it the difference? No, that is a plus sign, folks. That is not a difference. Have I given you any other way to factor two terms besides the difference of perfect squares? Did I tell you anything about a sum of perfect squares? No, because you can't do it. It's prime. No, 23 is not prime. Because, do you have a GCF in number 23? What can you take out? If you take out a 5, what's left? So, how many terms do you have in there? So, if you're going to do two terms, it has to be the difference of perfect squares. Is this the difference? No. So, you can't go any farther, but don't write prime, folks, because you already did something to it. You already took out a 5, right? So, you're just going to leave that as is. Don't write prime because you already took something out, but you can't take it any farther. That's the final answer right there, yep. Okay, let's go back to number 4 now, the one that Cheyenne was asking me about. Now, if I were you, and I haven't taken these notes before, I would say what Cheyenne said, and she said flip it around, right? Right? But if you look, that 100 is a perfect square, isn't it? Is the t squared a perfect square? Uh-huh. So why don't we do the difference of two squares? Which means I'm going to make conjugates. How am I going to make that 100? How am I going to make the t squared? T and t? What do you know about conjugates? There you go. Did that answer your question okay, Cheyenne? Yep, just leave it backwards. Which means we should also be able to do number 16, which looks like this. There's no GCF there, right? Is this the difference of two squares? So we're going to make conjugates. 1, 1, right? 21, 21. Don't forget to put what on those 21s? J's. And then we have 1 plus 1 minus. Okay, let's go right above it. Actually, no. Let's go to number 13, right in the beginning of that line. 13. Do you have a GCF? A U. You can take a U out of both of these. If you take a U out, what's left? Okay, how many terms you got in there now? 2, which means they need to be the difference of perfect squares. Is it the difference of perfect squares? Okay, so we're making conjugates. 2u and 2u, and then 3 and 3, plus minus. Told you these were going to be easy, right? As long as you know the pattern, they are easy. Let's go to number 12 now. Got a GCF? What is it? What's left? How many terms you got? 2. Is that the difference of perfect squares in there? Drop down that front 2. Make your conjugates. Good. Oh, let's see here. Did we already do number 6? Did we already do 18? Okay, let's go down to 18. Got a GCF there for me? More than that. We can take out a 3n cubed. Oops, I just put a squared. I said cubed and I put a squared. If you take out a 3n cubed, what's left? How many terms you got in there? 2. Is that the difference of perfect squares? It is. So drop down your 3n to the third and make conjugates. 1 plus 1 minus. It does not. Nope. And I think 19 is going to be the last one before we move on to something else. In number 19, can you take a GCF out? 5x. What's left? Okay. How many terms do you have in there? Are they the difference of perfect squares? So drop down your 5x, and we need to make conjugates. Symbols? Good. Is that all my 2-term problems? Okay, so all that's left now should be 3 terms. Like number 2. 3 terms. Now, you could say, yep, there's no GCF. Yep, it doesn't start with a 1. So, yep, I'm going to go the long way. If you were going to do that, you would have to multiply 49 and 9. What is 49 times 9, folks? Too big, right? I don't want to deal with that, do you? Okay, well, I need you to realize something. 49 and 9 are perfect squares. How do you make 49? And how do you make 9? If you multiply 7 and 3, what do you get? If you double 21, what do you get? Check it out. Y'all see that? Okay, so I'm going to go ahead and make my binomial times a binomial because, folks, it is 3 terms after all, and we always make binomials times binomials in 3 terms, don't we? This would be, like Gabby called it, the medium way. Okay, so how am I going to make this 49u squared? How am I going to make the 9? Now, do my symbols need to be the same or different? And they both need to be. There we go. Okay? Okay. How about number 5? Do you have a GCF? Higher than 3. 9. So we're going to divide all of these by 9. What's left if you take out a 9? Okay, how we doing, folks? Now that's 3 terms, right? Right? Automatically, for 3 terms, I know I need to do a binomial times a binomial. You can look at it and you can say, it doesn't start with a 1, so I'm going to do it the long way, right? Or you can notice 16's a perfect square and 1's a perfect square. Multiply 4 and 1 and you get 4. Double it and you get 8. So, how are you going to make 16k squared? How are you going to make 1? Do my symbols need to be the same or different? And they both need to be, there we go. What's that? You're about done with it already? Same thing over and over again. Number 8. You got a GCF? Nope. You could say long way, or you could say, hey, 25 is a perfect square, and 1's a perfect square. What do you get when you multiply them? 5. What do you get when you double it? Oh, whoa, whoa, whoa. 5 times 1 is 5, right? 5 times 1 is 5. If you double 5, what do you get? 10. Is that a 10 in there? So can we do this handy dandy thing we've been doing? No. Because you can't do anything with it. Well, there isn't any solution to any of these. There's no equal sign. You know what I mean? You can't solve them if there's no equal sign. None of them have an equal sign. All you can do is simplify it. But if you can't simplify it, then we write prime. How about we do one more? We'll call it, we can do one more. We can do 10. 10. I like 10 because A doesn't have a GCF. B, there's 3 terms. And C, it's the short way. It starts with a 1. I don't need to do any of this perfect square nonsense we've been doing today. What am I going to start them with? What am I going to end them with? I need factors of 72 that subtract to 1. 9 and 8. Do the symbols need to be the same or different? And the bigger one needs to be... Okay. So, folks, the rest on there you can do for extra credit. And I have a worksheet for you for homework.